It's my old project. Here we go. Skip number 2. Hopefully my machine runs faster today. Yep. Why doesn't it ever pick up the names? It's pretty frustrating how it doesn't pick up the names. Hmm. Gusting effect. Think. Okay. Hmm. 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 Let me think here. Nope. Stop. There it is. Attribute. Name. There we go. How many names are there? There is. Yep. Okay. Let's see. So far, I don't think you're on. But if you did just jump on, I am just making some quick things. This is just a version of that add make points thing I told you about last time. So I need to get 2 things. I need to get the string and for the names, points, 1 name, and it's was is 0.1 p I. Then we'll say point equals add points to was set point attribute 0 name n point n and then set, I think it is. So that should give me points with the names. It has not, so the reason being is I didn't back up. There we go. So now I've got all the names are just the same name. Yes, okay. Turn off that correct names. So now I've got the correct names. Okay. That all I was doing is I was doing this the add point thing, and then transfer attributes, the name, but in a vector angle here. So that's all I was doing. And so I'm going to be running some tests on this to see if we can make what you want done faster and easier. And I've reset my computer. Well, I haven't reset my computer. I've reset a portion of the computer to, let's take that down, scatter. Be lovely if I could actually get this to be uniformly distributed, but it's not going to, is it? Sometimes the ISO offset works better, honestly. It's very frustrating. It's very frustrating why the ISO works a bit better than the VDB sometimes. Anyway, so that's just my Voronoi. That's just a quick shatter. About, how many pieces is that? 1,000 roughly. And I'm just creating the points. Then what I can do is, if I go to assemble, like so, turn off the name, create pack geometry, I can then do transform pieces, I think, and match it to the name. Doesn't want to. Just take a look why. So piece 101 the same. Because this one doesn't have any packed attributes, that's why. So that's fine. Don't need that for now, because we can just get the transform and add it to this. So what I want to do is try and vect these without using dots for now. So there's two methods we can do. We can do like a VDB and a grid and have the VDB push out. So something like a box here. Box is really hard to see. I'm going to take the y component, add it there, and times by half. So that's just going to stick to the floor. Just going to make this a little bit bigger, like that. And then what I can do is I can convert that to VDB. Turn that off. Honestly, I don't need the density, I just need the velocity. So I say val. We don't have a velocity here, so we say point P instead. This part doesn't really matter, but I keep it to displacement velocity so that it doesn't normalize anything. But that's only if we are getting something from the position, from the velocity there. I need to fill that as well. And then I can put volume trail here. And so that's kind of what is going to happen to our volume right now. So let's volume up, add a volume up here. Let's add some noise. So bind exports, we are exporting to the velocity. Don't need to import the velocity because I'm making a new one. I'm going to make it constant. Actually, I'm going to make a parameter so I can edit it up there, up above here. I'm going to put down direction. You keep the names like lowercase. Direction. Keep it to a vector. Plug that in. And then I can set it to whatever I want. So I'm going to set it to be going that way for now. And I'm also just going to quickly noise it up. And I'll show why in a second. So I'm going to add to that a curl noise. Like that. And I'm just going to turn the amplitude right down, because I don't want it to be doing it. So this volume trail is basically what we want it to do, but not give us this, if that makes sense. So a way we can do this is we can do something called a VDB advect. VDB advect points, I should say. So we plug in the points advect, then we plug in the velocity, turn it on, and you can see something kind of moved. Unfortunately, it doesn't really do anything here. So what we have to do is put this into a for loop so that it goes over each time. So I'm going to say for we say for number. So because we're going to go over, we're not doing over each point. We're going to go over every point about 10 times. So I'm going to plug this one in first here. Plug that one in there. And what we want to do is, instead of merge each iteration, we want to say feedback each iteration. So ideally, that would affect them. It's not affecting them, which is kind of annoying. So it's fetching the input. We need to say fetch feedback as well here. And so now that is what it'll look like, given how many substeps we want. And it stops here because it goes outside of the volume block. And that could be what you want if it just stops there, sort of thing. But we don't quite want that just yet. So what we would do is we would extend this. We would extend the box 8. So that the box, that's how long the box is going to be, and then we would probably just move the box a little bit as well, so that it starts out closer to it. Then we get something like that. So so let's try and take this here. So let's move it by about that much, and let's try and push this onto this these points here. The probably the easiest way is to say we get point. So each point has its own name attribute, as these ones do. So we want to match the name attribute up. So I can say find attribute bell. I can say 1, the name, it's a point class. The name is what we want to get. We want to match it to my name. And I want to say it's the point that we're getting. And I've shown this a few times. So then we want to get the back position of that point. So I'm going to say point 1 p point. Then ideally I could just say equals plus. So now we're going to get like this this thing working, and you can see it's not quite, it is still leaving this trail here. So the reason we're doing this advection outside of the outside of all the bounds is so that we can test for, let's say, because we can do this in pops, obviously. So that's one way we could do it. But as you can see, we do have that limitation of the once it goes outside of the VDB, it kind of just dies. So another way, we could probably do this. Let's bring this down here, and I'm just going to kill it. Is we would have like there's a few other ways actually. So we would have I think it depends on how many positions we wanted to have, basically. So we could randomize the order. So if I transform this, and ideally I would randomize the name as well, but I don't really know how I could randomize the name. So let's see if we can randomize. Cannot. How about a sort? Can a sort work? So instead of using the name, we could use like the point number. So I'm going to say random. So it's just randomizing the point sort. So I'm just going to move this back a little bit, and then I'm going to take a point up, and we're going to merge between the two positions. So what we can do is we can bring in the point. So import point attribute. The point number is going to be this one, file is the second input, it's the position that we want. So if we plug that in, then we're going to get that. We can do a mix between the two. Honestly, that doesn't look that great. But the reason I'm showing this is because we have actually, a better thing to do would be to come back here and grab this. And grab this here for now. Let's turn that off. Let's pop this into a pop network. And let's do what we were doing down here. So we're going to take all the points on here. I'm going to keep the birth at the same for now, so that it's always going to be emitting. I'm going to say pop advect by volumes. It's the second input. So we're going to get that, which is kind of nice. And here, because you wanted a very simple method here, we would have, so let's take this here. Let's delete a few of these points. So we only have like maybe 4. So attribute wrangle. Let's use the detail. So let's do a for loop. So for integer I equals 0, I is less than n points of incoming I plus. It's just a for loop, so I'm going to go over every point. I'm going to say, I'm going to put down a counter. Oh wait, no, I can just use the counter here. So I'm going to say if II is greater than, let's say, a channel input of max points. So I can dynamically change it. I can just say remove point 0 II. So now we should have a few points here. It's kind of not working. So let's sort it, and let's just change the point number. So random until we get one that we kind of like. Oh, this one. Let's just bring it down a little bit. So we're only going to have about 4 points. Then what I want to do is I'm going to do a copy to points. Let's make a sphere. Let's turn these spheres into polygons, and we can noise them up. So let's go mountain. Let's just noise them up, so they're going to be kind of the same, which isn't really what we want. I'm not too sure how to change that. In here, make another let's make a point block actually, so that it's a bit easier for you to understand. Point block. What we want to do is I want to scale these over time. So let's just bring this down just so we can see it a little bit better. And let's turn off the mountain just for now. So over time, I want these to increase over a random period of time. So let's say we're going to grab the time, or I can grab the frame actually. Frame probably be a bit better. So I'm going to grab the frame. I'm going to say mix. So that's going to be my bias. I'm going to, these are going to be my min and max points. I'm going to blend that out into, let's say, and export the p-scale. P-scale is a float attribute. And because it's going greater than, this is a linear interpolation, and it's saying the bias is going above 0 to 1. We want to fit that back to 0 and 1. So what we can do is say fit range, and then we can set the amount of frames that it's going to go between. So let's say between frames 80. as you can see, they're going to expand over that 80 period. Let's give it a bit more randomness. So let's say random. Let's plug in the point number as a random, and let's plug in the source minimum, second random, and the source max. And what I'm going to do here is I'm going to fit range these as well. So I'm going to set the minimum that these can be. So the minimum this can be is about 40. The maximum this can be is about 80. Let's say that was wrong. So I'm also going to add constant to this point here. This one has to be a integer value, annoyingly, and it doesn't seem to be working. So let's see what we've done wrong. So alright, so the source, so we want to keep these at that, and I want this one to be between 40 and this one to be between 80. Interesting why that starts out at the wrong one. Let's just sort out that one. So the source minimum can change. The source minimum can change from 0 to about 50. Let's change it from that to change it back to change it to 70, and let's add a seed to it so that they're all a little bit different. Okay, but they're all still ending at the same frame. It's not quite what I want. So let's go source max, and let's push this from, let's say, from 70 till so they're all going to go up at their own different speed. And finally, we want to give it a random between, well, I want to keep the 0 the same, so I'm going to say min, call it min, it's max, and what I'm going to do here is I'm going to put down another random and another fit range. Plug the fit into there, plug the random into there, into the point number, and then the max I can change later on. So I'm going to say plug that one to there. I'm going to say max min, max min. So I want to plug that into the source minimum here. Or do I? I suppose it was working fine over there. It's a bit weird dealing with ops when I'm so used to Vex. So I'm going to keep it about there. Some of them are going to go a bit faster, some of them not, but you can change that using this as well. And a few of these seeds. Or not. Let's change this seed here. So add constant. So this one is going to be called seed min. Turn that off. Let's go add again. Let's make this one seed max. Actually, I'm not looking at the comments, am I? Can you take head instead of that? Yes, I can. Sorry, I didn't say that. Let's grab this and let's go seed p-scale. So now I've got a seed for the p-scale sort of thing. I don't like it. Well, it's not. Oh right, I want the this one to be the minimum here, not there. Okay, that makes sense. Okay, there we go. Now why isn't that changing the P scale for me? So the P scale is changing. This one here isn't changing it though. It should be changing it, but it's not. Alright. We'll deal with that later. So you wanted me to use a head instead. That's fine. So I'm going to put a head. Wrong one. Template head. I am actually just going to fill it. Do it like a polyfill. Because I like working with like solid geometry instead of just poly extruding it out. So let's. Where are you? Who's there? That's Francis. I'll share this one to Francis as well. What do you reckon about Francis's work? He's been working on this for like a few months. From the explosion course. Okay, let's plug that head. Actually, I want to polyfill this again. Polyfill. Change it from that to triangles, and then I'm just going to remesh it. And let's turn those iterations quite high. Okay. Plug that into there. Get rid of you. There. Make sure we're working. Yes, you are. You definitely are, Francis. To my one other viewer. So that's fracture it, and I think the problem with this is that okay, it's working. Stuff like that. Yep. So having this copy to points, I'm going to change this P scale because I want it to be a lot smaller. Okay. So let's take a look at the head first. There's the head. There's the head. Let's take a look at these. So it's going to be doing that to them. Let's add some noise to that. And there is no real way of making it noisy across each separate one, unfortunately. Also going to turn that down a little bit. Okay. Will to actually get have any issues? It should not, because we are. Do we have a UV? We have a UV. So let's grab our UV quick shade here, and let's take a look at our UV over here. A UV here. So it's just gonna wobble it a bit from this one, which is a little unusual. So I think there was another one. I think like UV splits before we do the remesh, and that kind of helps it a little bit, so that it still has a bit of distortion. Does it have that distortion before? Yes, it does. But the UV split will help a little bit with the UVs. Okay. What did I do? I just hit save. Okay, so that's our mountain. Here. Side here now we have this. Might prove to be a bit better if we grab a trail first. So let's go a trail, and with that we can actually visualize this noise a little bit better. So let's maybe increase the frequency. Bring that right down though. And maybe let's add another one, different type on top. So let's add position. Let's add to that. It's a 3D noise. Let's turn this the scale right up. And let's use a sparse convolution because that's -1 to 1. If we turn it up too high though, it's going to be a little bit messy. So let's go with 2. 2 looks alright to me, honestly. It's maybe a little bit too strong, but it looks good for now. So what I'm going to do here is, once we've got that one, I'm going to bring in this mountain here. And I'm going to make a grouping. So if it's in the group, activate. So it's group. Pop group. Bounding box. So we're going to say bounding box from bounding object, and it's going to be a SOP. It's going to be our third input. It's just going to do that anyway. So we're going to say preserve group as well. I'm going to say the group name is activate, and this one's only going to go on the group activate. And it's kind of popping in, isn't it? That's a little unusual. That's fine. We now need to do is we've got this working. So let's just quickly make sure that is still working with our attribute here. It shouldn't be working because one thing, this needs to be above here. Why does that look like that? That's absolutely horrible. Give me a second while I check some files. And the backup on the backups. Let's grab you. So I'm grabbing the old import Houdini digital asset. I'm grabbing the old Voronoi fracture. Sometimes that will work. If you want, I can give it to you. So install and create, and it's all the way down here. The reason we don't use this one anymore is because the other one's got a lot more vex involved, but it can produce issues like the ones you're seeing there. So that looks a lot nicer. Yep. Okay, cool. So that one's looking a lot nicer. Let's grab you. And so what's going to happen is it's going to kind of intersect with itself, which isn't really what we want. Oh. So instead of doing a popnet, what you could do is you could do a rigid body solver. So I'll just quickly showcase that. I'll get rid of this rigid body solver. So first input is going to be the packed geometry, and instead of this, it's going to be this beautiful assemble. Yeah. So now, ideally, what's going to happen is it's going to, even though it's going to be vecting along there, it should be hitting itself. Yes. Isn't it wonderful when things work? That's very slow. So yep, let's just stick with particles for now. Solve. Let's get rid of you. Yeah, I don't know why the rigid body solve is so slow lately. And let's just quickly take a look at the side effects changelog, and let's see if they made any changes to the bullet. So let's go to bullets. Okay, bullet solver avoided. Yeah, okay, thank you. Fix the bug, fix the bug. What version of bullet are we using? Nope. 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 Oh. Interesting. That's kind of annoying. Maybe. That was nice. I had that one a lot. Okay, bullet 2.86. So let's take a look at the current bullet solver. So if we go bullet solver, what version of bullet do we currently have? Let's go about, show details. It's not going to tell me. Cool. So, I believe bullet has been updated to 3.05 and Houdini is still running 2.7. Makes sense, it's more stable. But okay, so the pop is working, but we're not having that interaction with each other. So we could probably have it, and you can see it's still kind of slowing down, stopping when it's getting out of the range of that. So what we can do is we can set a expression here. So if I just go pass through here, we've got the force ramp, air resistance, velocity scale. A little similar. Let's take a look. Send me a file. um, come on. Someone's been using Arnold. Root blurring the position. Fair enough. Up, removing all the attributes. Good. And then deleting all the groups. Cool. Spreading the source. Is this yours? Let me just go to my normal viewpoint. No, okay. Let me turn off that so I can say. That's the spreading, the noise cool. Yep, okay. Got it from Vimeo. Right. Then it's doing like a see what the attribute transfer. Oh, I say, yep. So we have that. Let's go back out to the Sims. Let's see what they're doing with the Sims. Stop. Stop. So it's got the source subdividing. It's remeshing. Why are you remeshing a subdivide? That's so annoying. Okay, yep, you're doing an attribute transfer, I'd say. Yes, you are. Can you show me which video you got it from? Okay, so then, yep, point up to noise that up. Oh, okay, that's cool. Yep, I see. Yeah, that's fair. Ooh, okay. Okay, let's take a look at the sim. They're doing a rock source and a sound source. Wind, yeah, turbulences, that's good. And we've got the traction. Spinning, stuff like that. Okay, cool. That's actually a really nice way of doing it. Giving the points that are being vectored out more positions. So, that's quite nice. I really do like that. That is very, very, very cool. Um, hmm. Who did this? Who did this? Hmm. I've never heard of this person. That is very cool though. He's an follow. Um. Okay. Yep. 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 Do you understand what he's doing in here, by any chance? Okay. I'll just continue on with this one for now. Full scale, full scale. Okay, cool. So I'm going to say distance from. Okay, so I want to say fit range, fit. distance between at P and 0, so I'm lazy. Between 0 and let's say 10 to 1 0. So that way it's going to go, the force is going to go down, basically. So that's a very cool way of doing it. I'm not going to add, I might add one force. I'll add one to force. So force in here, and I honestly want it to be a little bit less than that, because I want this one to be holding more on it. Not too sure why it's doing that. Why is it just taking over the that? It's rather nasty. Let's put this in first. See if that does anything. No, it doesn't do anything to change it. Oh, right, because these probably need to be in the activated group too. So it's going to go to the group activate. It looks a little bit better, but I also want to turn the amplitude down so that as it gets further out, it's just going to get worse and worse. So 0 and 1, 2. I'll copy that. I'll go here. I say amplitude by age. I'm going to go like that. So that the further it gets out. So if it goes 10, I want it to be at like 0. Sort of thing. Okay. So basically I'm slowly turning off the force. And I think that might be still be too strong, so I'm going to say 0.25. I'm going to say between that and let's say 5, and this one between that and 5 as well. And I'll show you why I'm doing this soon, I promise. Okay. Now then, what I want to do is I'm just going to disconnect that, and I'm going to make sure that that's going into there instead of the assemble. And so what should happen now is if I dot import, actually I'm going to say dot import fields because it's a little bit nicer. Dot import fields just a wrapper over the dot import. So pop object. I'm going to say choose particles. It's just going to give me the geometry field. So now we've got that. Let's make sure we're getting all the attributes we want. So it has the name, 1000 unique. Yeah, 1000 unique. Okay. So it's giving us the name. It's giving us the ID. So the name is technically what we want, because we can just connect to the name. So now what we could do is we could put down an add node. Let's go add delete geometry by group, by attribute, by name. And so now we're going to get something absolutely horrible. Ideally we use by ID, but we don't have an ID here. So let's add an ID. So I at ID equals that point number. And what I'm going to do is under the attributes, under the birth, where is it? One of these things here overwrites my ID. One of these does. See, add ID attributes here. So I'm just going to turn that off. Now we're going to get something a bit like that. And we're probably going to have to turn down one or more of these. So I'm going to turn this right down to about 0.1. Let's scale this down to about 0.5. No, that's fine. I know. I'm just doing some stuff here. So honestly, I think I might be taking a longer route than I want to be. Let's go down to U. Let's increase that trail length. I want, so we, I'll keep this one here because I spent time on it. But what I'm going to do is I'm going to say delete if ID does not equal, let's say, or is less than equal to, let's say, ID thing, then remove the points. ID. Surely that should be working. Why is it not working? Okay, there we go. So now we've got a few of these. Let's just do this add part here. Let's do a few more. I'm going to really smooth these out. Also going to add it in a resample so that they're not smoothing out too much. Okay. And what I want to do with these is I want to make these like a force sort of thing, and I'll show you how I'm going to do that. So you're obviously aware of, I'm going to do the same sort of thing here. I know that you're aware of like the the curve force, I believe. So I'm going to plug this into the second input, this one into the first. So you're aware of the curve force, which is the curve force sort of thing here, where we go grab the second input, and then we have this massively massive thing here, which doesn't quite work. Also, this needs to be probably frozen in time. So I'm going to have to time freeze this, save this out quickly. Where's a good frame? About there-ish. So let's just do a time freeze, time shift. And honestly, this is probably better to just use this one instead, but I'm going to stick with what I did because that was just a bad mistake on my part. Okay, file cache. I'm just going to cache this out quickly. Save the current frame. Geo. It is the push along curve. Save. Load. Okay. So now we're getting that. And honestly, we could probably push this. I'm going to set it to turn. I'm going to push this about 800. Let's turn that resample down a little bit, because we do want it to have some sort of twisting, but we don't want that much. Okay. And so you're obviously aware of the pop curve force, which is going to look something like this, which looks absolutely hideous. So let's turn this down a little bit. And I'm feeling it's going the wrong way. So what we would need to do, the problem with this one is that it has like a radius, and if it goes outside the radius, it just dies. So I'm going to quickly show you how to do this in a wrangle, not a wrangle, can't remember what it's called. For now, I want to set the velocity to be the other way. So I'm just going to do, I'm going to set the, where is the velocity? So I say v at v equals normalize, just so I can see it, v. Can we see the velocity? I can't. Take a look. Make sure it does have a velocity. It does, but I can't really see it. Okay, now there it is. Wonder why it wasn't showing up beforehand. So there's our velocity. I'm also going to increase the resample here, this one, because I want quite a few points, and you'll see why in a second. That's our velocity. I might want to invert it, so I'm going to say v at v equals negative v at v. And that's just going to invert it for me. And that's all the attributes I need on there. So what we're going to do here is we're going to do another point cloud, which is point pop. Come on, where's the pop? Pop. Also actually going to grab the grouping that we had as well, so that we can mimic that. So let me just grab this pop group activate. Pop group activate. There we go. It's the third context, is it? Yes, it is the third context. Okay. So now we're going to get that. I'm going to say activate like that. Okay. What I want to do is showcase how the follow curve kind of works, but a little bit nicer. So I'm going to say pop, pop, plug it in. I'm going to say the second input here is going to be my second input from here. So it's going to grab this, and whoops. And then I'm going to bind it in here. And what I want to do is I want to say point clouds open. I'm going to promote the radius up and promote the parameters up. I know, can we already use existing force instead of velocity? So I'll show why we're using the velocity here. Let's just grab the position. This is rather simple in a sense. So what I want to do, let me figure out what exactly I want to do. Where's that old tutorial? That old Chinese one. Just so that I do know what I'm doing. Who made it? Come on. Was this person? No. It's him. So there is this person. No, it's not. This one. It was this one. So there was a tutorial came out a little while ago. Turn the volume down on this thing and just skip to what I want, which is that image. Come on. Okay, so to get like the velocity from what we want, so I'm going to say subtract, because I want to get the position of these points. So I'm going to say subtract. Here I'm going to switch these around, and I'm going to plug that into the force. Brilliant. Let's plug it into the velocity first. Actually, we've got to expand this, so I'm going to say about 1,000, and then I'm going to say number of points, but to about 50. Okay. So the file channel also has to be into the second input here. Okay. So that should be working. We gain the P of this channel here, getting the position here of this one, gain here, getting the max radius, And we are subtracting it. Basically what we're trying to do is we're trying to get like a suction force currently. So the suction force should be coming in. So let's grab, hang on, all points. So now this is going to be sucking into the wrangles, but it's only going to be sucking into like the first point. It's almost what we want. We want to now push it along the curve. So the way we do that, I believe, is we get the because we've already got this one, we can just say, yep, I want to get the velocity, and I can just add this to here. Oops, to the velocity here. And it's going the wrong way. Great. So let's go back here and not negate it. So now it's going to be kind of following along those curves. But what I also want to do is I want to have like a how do I put it? Like a spinning a little bit. So the way we can do that is we can do something called cross product. And the video is not showing me what I want. Yep, okay. So we do that by you getting the current position and the current velocity. So let's say cross product here. Both of these need to be normalized, but I'm not going to do that. I'm actually going to do that, sorry. So plug these in to normalize. And if I plug that directly into the velocity, what should happen, ideally, is we should get like a spinning. So we're getting some sort of spinning motion here. Someone keeps messaging me. Then what we want to do is we want to add that to here. These things. And it's kind of not really working. So it could be because we need to have this one being this position here. There we go. Now we're getting some form of spinning, just a very, very poor one. See if I'm getting the right one. Okay, well, that's that. But you also had the fact that we also want to get more of the details, so like it's dusting away. So let's try and do that. So this is just some setups, I suppose. It's kind of hard to show something that I haven't done any R&D on myself. So this is my R&D, ideally. Okay, so let's try and dust away this head a little bit. I'm going to try and dust away. Let's make a null. And I want to dust away like this part of the head here. So I'm going to say out, head, color it, grab it, close it, open it. Let's try and actually make something out of this. Like an NFT or something. So what that person had was really, really good, where it had like this this effect where it would change it, like it would get like a more dense and stuff. So what I'm going to do is I'm going to go back up. I'm going to scatter about 4,000 points on here. And I'm just going to be using the point bobs from now on. So I'm definitely going to try and make it a lot more simpler than I just was trying to do it, because yeah, that wasn't quite as simple as it should be. Okay, let's just check the coloring. Cool. We still are having a bit of issues here, but that's fine, really. Okay, so jump back up. So now we've got this lovely thing. And honestly, I'm just going to delete some attributes now. I really should have done it beforehand. Attribute delete and group delete. So honestly, as I said, I should have done this beforehand. I did anything, so I want to keep those. I don't want material, and I don't want that. So those things I do want, and then the groups, I don't need any of the groups. Okay. Again, as I said, I should have done this before. But now, so what I'm going to do is let's explode it to see how big it is. So it's kind of nice and small, but we would like it a bit smaller. So we can do for each down here. We'll do that later. Now I want these to be pushing outwards. And there's several ways you can do this. So I'm going to say point up, and I'm going to assemble it. So that we're getting packed attributes. I'm going to turn off the name. That's already got a name. And we can say add. Let's say add to vector. It's like a set vector component sort of thing. So I can say set vector component or add vector component, but I just want to add to it, so I'm going to say vector to float and float to vector for now. Plug that in, plug those in, that's the same. And I want to change one of these. So with the time incremental, I want to change that. So I'm going to say add. Let's do the Z instead. Well, I mean the X. Sorry, not that one. Okay. So that's going to increase that one over time. Let's try and make it go more of like a gradient sort of thing. So let's say fit range. Fit, and we're going to fit. We can fit this thing between it. We don't really want it to. Let's fit this one here. Let's fit this. How would I do that? How would I make it dust off without going into like the pops? But I would do that thing I did over here, which was this thing here. So I'm going to grab all that, jump back up, delete that, paste this in here. Let's move these just for now. And you don't like what? Okay, so I need to turn off the assemble. Get rid of that pop network. Where was the other one? Here. Scrap you. Pop network. Let's plug you in. Plug you in. Okay. So that's already pushing it too much. If you don't want to have it in like a this, we can add it to like a solver instead. So show you how to do that. So let's say solver, this geometry, add that. And what you would do here is you'd have like a scaling, like a drag. So let's say if we say attribute wrangle here, I'm going to say at p plus equals b at b, sort of thing. If, for example, this had a velocity, so let's initialize that. So let's say velocity equals set 0, 0, 1. So it's going to be pushing along one side. Old geometry fetched, okay. You're going to see it's going to like shoot off really, really fast. So let's add a bit of air resistance. Let's try and scale this down. So scale channel, so like this. So b at b times equals channel force drag it. So I'm going to set it to about 0.5. You don't even see it working. Let's make it a bit bigger. Unusual why it's doing that. Well, it's just anyway, so VDB active advect. Where's advect? Advect points. We grab this, we plug this in here, we plug this into the second one here. Then we have that working. But again, we're still going to get the this not quite working as how we wanted it to. So let's take a look. Let's think. Let's try and think about how we can lerp it between these positions. So there is a thing that we can use. So I'm going to add in. I'm going to make a few things. So what I'm going to do is I'm going to say transform here. I'm going to push this over a little bit and to this like that. Next one, I'm going to push this one over and back like that. And then I'm going to apply these two into like a rest. So I'm going to say v vector rest 1 equal point 1 p point number vector rest 2 point 1 p 2 sorry 2 p point number. So now I've got two of the rests in here, and what I want to do is I want to basically linearly I want to blend between. So blend, I've got like a blend. So you've got a few blend ways here. I've never seen most of these, honestly. But basically what it would do is you'd plug in these three sources here. And you would blend between, so we've got two ones here. So you blend between the two. But it doesn't quite properly blend it, so I'd like it to have like more of a curve than anything. So in video games, I've got too many tabs open, can't show them. In video games, so we can say lerp, is it Unity? So there is a. So if we, I've got to try and think of the name. Sorry, my brain's kind of being fried. Francis, help. Um, there is a technique which I cannot think of now. It's like a let's try and figure out what that name is first. Hmm. Okay. So there is a thing called quadratic linear or Bezier curve, basically. So what that would do is we would say, hey, um, if I said add here, I went merge. So say merge all these three things, merge all these three things here together. I say add by nope, by attribute. Let's say I think would be ID I want. Nope. Let's say by name. So what we have here is we have like a linear curve, but if I then resample each one, actually no, if I convert each one like so into a Bezier curve, you can see it's got this smoother interpolation between the two. And that's basically what I want to do, just in, well, not in code, because I don't want to confuse you. So there's the way that they do it is we have like a linear interpolation between the two. And there are several ways of showcasing that, in the sense of, like, so far I'm just going to bring you my tabs. So we've got this one here, how to work with Bezier curves, and it's showing how it's doing it. So it's taking it's getting the intermediate point between the two. So it's going from 0 to 1. This one here, the quadratic Bezier curves. So you've got quadratic and you've got cubic, and cubic is has 4 control points. Quadratic has 3. And then you've got the code here, which is quite nice. It's kind of what we want. And you can see how it's being used in the game. But what it's doing is it's taking the first one, and it's basically, let's say you're interpolating between this one and this point here, and then you're interpolating between this point and this point, and then you're interpolating between this point and this point. And that's how we get this curved sort of thing, and this one's just doing it for each of them. There's a better one here, where it is actually showing us the code for it all, which is quite nice. You can see how it's moving along. So it's getting this. Oops. So it's saying it's using a quadratic formula instead of vector lerp. We don't need to do a quadratic formula. We can just use the lerp function, honestly. So and you can see the different amount of points it's going to give it to each one. So let us try and figure that out, shall we? Or do you want to try and, because my brain is frying a little bit. I'm not thinking too straight, so it's kind of hard to think of a way to do this. Okay, so I'm just going to keep this here for now. And what I'm going to do is I'm going to make some functions. So it's Alt E, make these nice and big. And I'm just literally going to copy paste what the code that I just showed you there into here, and we're going to make it work. So we don't need to have that there. We can just say it is a vector. Okay. In tab these, hit apply again, and we're going to do a bit more work. So this one's just going to be called vector, lowercase. This one's called vector as well. This one's called vector, and this one is called vector, and I missed the 3. Okay, so hit apply. Yeah. Okay, I see that. Hit accept. Okay. Hmm. Hmm. This one's very nice though. I'm probably because my brain is frying a little bit. This one will probably be the way to go because it's showcasing like that. But it's if you like that isn't this isn't complex at all. This one. So what the hell's going on there? Oh, right. Let me think. So if you really wanted to do it, you could just do this method, and you would mess with the correct way it should be flowing. So let's go blind trail. So let's make it go elsewhere. So I'm going to say along the X. I'm just going to say 0.1. So it's going that way a little bit. Let's turn down the complexity of all this. So I'm going to turn this right up. Let me think. So I'm going to hit a solver, grab the solver, grab U, and I want to just say VDB advect for now. So VDB advect points, grab the previous frame in here, grab this one in here, one, that, make sure that it's getting the val, and then that's just going to advect quite fast, unfortunately. So if you want to slow that down, we would do like a multiply. So multiply, and we'd say speed. So let's turn that speed right down. Maybe less. So that's that. I want to make it so that only a few pieces are working. So let's go back up to here. Let's grab this. Let's grab these things so that we can have like a growing or a grouping method. Okay. Don't like how they're doing that. I'm going to plug. Can I just plug it straight into here? No. So I'm going to grab this inside here. I'm then going to say add previous frame, this source data here. Let's go with the source data for now. And let's do a attribute wrangle. No, let's do a group. Sorry, a group. Let's do a grouping. And ideally, what should happen? So a group. I'm going to say for activated. I'm going to say bounding regions, bounding object, like so. And ideally, what should happen is the group should stay the same. Should hold on to it. So let's go color. Actually, no, it wouldn't, would it? So let's go color, let's go group, act, and let's change that. Yeah, it's not sticking with it for some reason. So let's try and figure that out. Let's plug it into the previous frame instead, so that it's going to get, oh, it's replacing it too. So we're going to say union with existing. And now that's going to work with what we want. Let's sort this a little bit better, so we get something more at the front. Okay. And again, this piece is still just bumping in. So that's really nasty how it's doing that. So I'm going to take all this and I'm going to plug it into a wrangle instead. So let's go attribute wrangle. So we want to randomize the p-scale over a period of time. So I'm going to say float r for the random. So I'm going to say random at float seed scale. I'm going to say plus at point number, and I put the float in first because otherwise I'd have to make this an integer. Okay, so then let's say f at p-scale equals r. Okay, cool. I want to fit range this, so let's say fit from 0 1 because the random gives me one range from 0 to 1. And let's say channel float min scale, channel float max scale. So 0 to 1. Let's change this to 0.2. Let's change to 0.5. I've still got a mountain to go. And then what I want to do is I want to make this grow over time. So I'm going to say float t for r time. So I'm going to say random. I'm going to do the same thing here. I'm just going to change that. I'm just going to change the seed here. So now we have a random scale for the seed. So I'm basically just copying everything I've done in here out. I'm then going to say float t for time, and I'm going to say fit at frame between 0 t is 0 to 1. I'm also going to clamp it so that it doesn't go over 0 to 1. Okay. I'm still streaming. Yes, I am, Francis. So now I need to play the indo. So what I want to do is I want to say, hey, fit range this between. I want to mix between the two. So I'm going to say f at p-scale equals linear interpolation between. So the first one's going to be 0, the second one's going to be 1. So it's at 0. Current p-scale that I'm getting from here by the time. And I've no idea how to check that. Frame, t, p-scale, 0 and 1, p-scale. Am I getting the right one? Is it frame? Please don't tell me I'm making a name called frame. Let's turn off the clamp. Oh, hang on. So it's this frame plus this one here. No, it's not. No, that's not right. So I need to fit range this one here. So I'm going to say fit 01 between minimum and maximum. So I'm going to say channel float min F, and channel float max. And I forgot one more bracket, so I'm going to put this between say 10 and this one between. And we can see that it's now kind of working. Hang on. It's still not right. Oh gosh. Hmm. So I want to randomize this one, I randomize that one. So what I want to do is I want to set return 2, C scale 3, and I am going to copy paste this one into here. So 1, 1. I'm going to renumber these. So this one is like the minimum frame time it can start. So I'm going to say it starts at 20, between 20 and 30. So that's when it can start, basically. Honestly, no, that's correct. Between 20 and 30, and then this one between 50 and 90. So now that's working. Okay, that was a little bit jumbled up. But now the grouping should now not just kind of splotch in. It's kind of is still splotching in, which is really annoying. Let's take a look at this. So some of these are like inverted. So let's check to make sure that the scale is between they're going the correct way. Okay, so it's the mountain that's making me up. Let's change that mountain. And the mountain is going to be the same for each one. So if we wanted to change it, we would have to do like a for loop. So we would say for each point here, copy points, chuck it into here. It's copied over here. This one gets copied here. This one gets copied here. Yep, like that. This one goes over here. And what we would do is we would just going to make a metadata here, and I'm just going to make a spare input, add spare input, plug that into there, and under the seed, the offset, I'm going to say random detail -1 for the spare input and iteration. Why don't you like it? Zero, because it's a just a 1 sort of thing. Ideally, so I'm going to. Where's the seed on this thing? There should be a seed. I'm going to arrange this one as well between let's say 0 and let's say 30. 40. So now we're going to have very different looking spheres. And it's going to look a bit weird because it's not propagating. And now it is. There we go. That's okay, you can interrupt as much as you want. Now what I want to do is I want to just plug that into here. And I'd say point group onto the act here. There's a thunderstorm, is there? Okay. Is your computer going to get shut down or something? I wonder if there is also another way of doing this. So the VDB vect, if we want to randomize the force that gets applied to it, right? We will need to. We can't use a VDB vect. So what we would do is we grab a wrangle instead, and we're going to do something very similar. We're going to get the vector, we're going to get the velocity from there, which is what this is doing, and we're going to only run it on the points. So I'm going to say active on points here. I'm going to say vector vel. It's going to be a volume sample. But actually, I'm going to do this in a point drop, because this is something I can do with point drop. Let's plug this in here. Plug this in here. Okay. So this one wants to be running over the group act, and we can grab something called a volume sample vector. So sample position. I'm going to say second input. That primitive name is velocity, and then what I can do is I can say add to position, and what that's going to do is it's going to hopefully be kind of similar, but it's just going to add it directly to it. So it's really not that great, honestly. So what we would do here then is we would just noise up this one here. So we want to noise up this in a better way. So currently they've all got basically the same amount of strength between them all. I want to change that. The way I can do that is with like a multiplier like I've got here. So I'm going to keep the multiplier here for now. But with this one, I want to multiply I'm going to normalize it so that it's all going to be 1. So as you can see here. And then I want to noise them up so that they're not all at a strength of 1. So I can do that with like a turbulent noise, and I'm going to say multiply. Plug that into here. Switch these around. And keep this at 1D noise. Float. And now I can increase this quite a bit. Which is if you need to. Do you not have power surge protectors? Also, if we wanted to make this a little bit nicer, we would add to the position another turbulent noise. And we make this one 3D. This would just mess with the initial one as well. Okay, let's take a look at that. So we will need to increase the speed quite a bit. So I'm going to keep streaming. I'm going to try and go to like an end point. If it does shut down for you, then you can still come back to where you left off and watch it. It's up to you. Honestly, as I said, I'm not doing 100% great, and this is not exactly a good looking thing. So it's up to you what you want to do. But I just thought another thing I could do here. So I'm going to turn off this normalize. I'm going to disconnect this. So now we're back to what this one was originally. I'm going to set, this is going to go too fast, so I'm going to set back to 0.1. and I want to say, hey, for the current point number, I'm going to get the previous frame here. I'm going to get the infected frame, and I'm going to say, hey, just let between the two. So I'm going to say here and here. Actually, I'm going to plug this into here so that we're going to keep the group propagation. And I'm going to say if actually I'm going to say floats r is going to be random. Let's say channel float seed plus at point number. That's going to get me a random between 0 and 1. Let's do this in a point block. I'm going to say lerp. I'm going to say mix. Sorry, mix is like the mixing between the two. So I'm going to say mix between these two. And now I'm going to say point import, import. Come on, import this. I'm going to go here. This the second input. Second input point number is this one. We're getting the position, and I want to randomize this. So I'm going to say random. So add. So let's say float to no, into float so that I can do what I want to do. So let's say into float is point number. Make that random. That's the bias here. I'm going to put a fit range so that it's always is going to move a little bit. So I'm going to say write these up. Then I'm going to say add to here. So that's the seed here. That's the point. So basically now I'm going to be mixing between the two. I'm going to say the minimum is going to be at least 0.4. So it is going to move a little bit, but now this way I have like this a random attribute that I can use to kind of randomize it a little bit more. If I want to really showcase that, so I'd turn down the minimum volume here and reset it. You can see some of the points just aren't moving at all. Honestly, I do like this quite a lot. In my tab, I don't understand what it is. Ah, okay, tablet, right. Did you want me to pause for a little bit while you set up? Actually, I'll just talk to you here. Okay, if you say so. So we've got this lovely little thing going on here. Let's try and pack it. So let's say pack. Why aren't we packing it? So pack. Oh right, so I need to pack it here. Let's try and pack this. Doesn't want it, so alright, because we need to actually plug it into there. It doesn't look very good, does it? So what I'm going to do is I'm going to set a point. So instead of this setup here, where we're grouping it, I'm just going to animate a sphere. So I'm going to say polygon, noise it up, so plug it mountain. So let's plug let's make it like that. Let's make that a bit smaller, and let's transform it. Make sure we're still seeing the head. Plug it into there. I'm going to scale this down. I'm going to move it up, move it across, away, move it across. So I want it to start kind of roughly about there. Let's just move it this speed. Okay. So I want that to just transform up a little bit. So and it's transforming from the middle to the region. All right. So I'm going to turn that off. Let's turn this scale right down as well. So let's turn this scale down. Let's increase this 5. And let's use the mountain after the fact. Maybe. I don't think I like that actually. So let's use the mountain for it. And let's just don't use it too much. Something like that. And then I'm going to go from, so frame 10. Let's scale it from 0 to about 50. Let's scale it up. Be about like that. Okay. Let's plug this back in here. And this grouping is going to go from the sphere input instead. And now we're going to see like it's now like pulling itself away, it's moving away, which is kind of what we want. But we also want it to split even further. And I do actually want it to be moving a bit more, so 0.5. And reset the simulation. And the reason I'm doing that again is so I can do that code I did last time. Maybe a bit less than that. So 2, let's go 0.2. Reset it. Reset it again. Okay. Honestly, that's still a little bit too much. So let's move this a bit slower, and let's go jump back up to here, and let's get some more points. So I want it to be a bit smaller, so let's go about I'm going to say 3 for this. Turn that off. I'm going to say 8,000 because I want these points to be nice and small. And honestly, it might prove to be better to just do the poly extrude again. Okay, it's still fracturing. I thought it finished. Let's jump back into here. Step back. Okay. Cool. So that's working. Let's take a look at our box. So the box can be fixed to be a bit better than that. So let's bring this in. Let's bring this in. Let's bring this down a little bit. Oops, I did the wrong thing. Let's bring that down. Bring that. Okay. Let's bring this down. Alright, because I've done that thing here as well. And let's make this just a little bit bigger. Okay, I'm going to hit close. I'm going to just type in the base 2.2. Turn you off. Make it 0. Maybe a bit higher than that, honestly. 2. So 0.2. 0. I like having like whole values. So I will mess with the gizmos, but at the end of the day, I like to have whole values. It's something I picked up from using Cinema 4D, where you can. It's very hard to do anything unless you have precise things, and then this just made it a little bit faster, honestly. And you can, of course, set the scale, the speed as it goes along, but we don't want to do that right now. So what I want to do is I'm just going to say color. We're not going to see the color, so we need to say attribute promote from point to primitive. Say color, and we can see the color now kind of activating across those things. And with you probably just do like a poly extrude on the head, honestly. But that's what we want. So now, what I want to do is I want to do that wrangle thing, where we have like the name and so on. So let's open up a new version, new Houdini, and I really would love to know why my Redshift is installed. What's this version? 4.547. Let's take a look at where Redshift is. Program data. Redshift. Plugins. Solaris. 547. So Redshift is kind of unique in the sense that it's annoying. They don't give you builds. Version 4.44. Is that new? It was published today. Okay. I'll grab it. I'll grab that. Yes, thank you. So now that Houdini is opened, I'm going to open up Testing Effect 01. Hit escape so that it doesn't do all that junk. So now I want to have this transform thing here. So, and I also want to have this age. I want to make an age on here. So what I'm going to do is I'm going to set attribute wrangle. Plug these in here. And what I'm going to do is I'm going to set int point to get the point we want. So I'm going to say find attrib val. So I want to find the same point with the same name. All versions there. Yes, well, not quite Redshift. Yeah, it's kind of hard to explain how the builds differ, but sometimes if you build it wrong, it just doesn't work. So, so it's one, we're going to get a point attribute because we're running over the points here with the same name. Points, we're kind of trying to find the name. The current name is my current name on here, and now that's going to give us the point. And now I want to get two matrices, which I discussed last time. So M3 is going to be prim intrinsic, 1 transform point. Oh wow, that was a fast download. Matrix. Wait, this needs to be matrix 3. Matrix M4. Here's another one. Trim intrinsic. I hope this works. 1. Packed. Full. Packed. Is that right? Packed. Full. Transform. 1. Point. Set the primitive intrinsic of my transform of this current point number to the matrix 3 that we described from here, from the second input. And I'm going to set that. Nothing happened, cool. And then I'm going to say at p times equals n4. Cool. So it still does work. That's really nice. I'm really glad about that. But now we want to have like an age on here. So what I can do is I'm going to say aspect angle down here. And I've lost it. There it is. All I'm going to do is I'm going to say if in group, all those in group are the f at age plus equals. Now we can either go by frame or by time increments. So let me think. Let's go by frame. Let's go by the current frame. And now what should happen is if we look at our primitives, we should have a, oh my word. Okay, so we want the frame increment. Oh no, we want to say frame 1. We just want to say +1. Okay, so each frame is just going to be adding to plus to that. Reset. And now we can see that some of these adding to their age. So let's take a look. If we want to properly get like a range, we would do like do several promotions, but we don't want to do that just yet. So I'm going to say ramp. Ramp from attributes. It is the age. I'm going to set it so the lower one's going to be red. This one's just going to be blue. And then we need to promote this back to primitive so that we can actually see the color. So we're not going to see anything yet because we need to fit this between the correct range. So the highest one is frame 69. So 69 frames, it's been alive. And now we can see that we have like this age sort of thing that we can linearly interpolate between. The reason I'm showing this is, let's go. We need to now just add the age from here onto these points over here, so that when these age 2, we're going to see it. So the way we can do that is we can say f at age equals 0.1 age point. And now we're just bringing our age over into here. Cool. So this one is set transforms and age. My workhorse, because I have unique names for everything. And the reason we do this is now we make a very high res version of these points. So we're going to say for each of these, and they're all going to have the same 7954. 7954. So for each of these, I want to, let's just piece attribute by like 10. So I want to scatter not 1,000 points, because that would just be incredibly stupid. But I want to scatter, well actually I do want to have that there. I'll show why later, but that's going to be for a separate one. So I've got this lovely thing here. I'm going to say, instead of this, I'm going to say by density scale. Let's make it a bit higher. So 4,000. So many points is that? That's 13 points. Let's make it 2,000 instead. So it's not so big. We could do an ISO offset and keep it in the middle, so let's just do that. So ISO offset, let's go by size of 0.01. Hopefully it's not going to be that slow. Okay, it's not actually working, so VDB from polygons. So add a VDB, and we can see that it's barely being touched, because this is so small. Is it even airtight? It should be airtight. It's not working. 1 by 1, okay. Let's go even smaller. Okay, so it is actually getting that, so it's unusual why this sketch isn't actually scattering on it. So let's, instead of this, I'm going to bring that back down to about 100, whatever, about 10 I think it was. So let's say force total count. And for this one, I am going to grab a metadata. I don't know if this is going to work, honestly. And under this scatter, I'm going to say relax iterations down to about 2. So the relaxed iteration is what makes it take time. I'm going to add a spare input further into there, and I'm going to make a random between the detail -1, the iteration 0. It's just an integer, and so this is going to go from 0 to 1. I got that, so I'm going to say fit by 1 between 1 and let's say 10. So now it's going to be from between 10 or whatever. So now we're going to get that. So now I'm going to do a Voronoi. Let's just use the default Voronoi, because that way we might be able to speed it up. Who knows? Okay. So now we've got that working. Let's see what happens when we turn off this max iterations. Let's take it at sweet time. Let's turn that off. Let's turn it back on. I'm going to say multi-thread. Let's compile, lock, plug you in. Plug you in. What's wrong? Nothing to tetrahedralize. How dare you? There is something to tetrahedralize. Turn it off. 2000, 4000, 5000, 7000. Done. So now, but this is going to give us a new name for each one. Honestly, this is really annoying. This tetrahedralize. So this tetrahedralize is coming from the Voronoi part. So some of them may not have enough points. So let's fix that. So let's say we need to have a minimum of about 4. Hopefully that'll get rid of those errors, because you can't just have 1 point. The point set is trivial. I don't know what that means. But now we're only going to have like 10 unique points. So let's go back and let's say max attributes, match points, about 200. Let's say 200 of these. Let's say 50. Make it a mixture between speed and stuff. So I want to now copy over the name of these so that we can go over them. So I'm going to say let's say attribute name, and these need to be set onto the primitives. So and the name's always going to be the same. So I'm going to say s at name equals the primitive for the prim, which is going to get this primitive attribute 1, the name, current primitive, and that's just always going to be 0. That's just going to be the one name. And now if we take a look, we should have 50 unique names. Like so. And so these are going to be matching these. You're not going to see anything on it though, because these need to be assembled under that name. 50, and it's packing unique. Oh, great. Turn off that create unique names. Okay. It's a little frustrating. That's actually pretty cool. Why is it doing that? Reset that simulation, please. Why is it doing that? Do you know what I've done wrong? Okay, cool. Glad the rain is over. Name. And I've kind of lost the plot a bit. Primitive. Oh, hang on. That needs to be assembled as well. I'm not very bright. And now that will now transform those points. Or not. Okay, there we go. Plug you in, and that is kind of transforming them. That's good. Alright, so, but now we also need to make a unique name. So I'm going to say s at name 2 is going to be the current name. So I need to make this before this override the name. So I'm going to say s at name is going to be sprint f. This is the formatting thing which I showed last time. So I'm going to say percentage sign B for version. So I'm going to say S. So version like that. Then let's say another. So actually, I'm going to say make this one D, so that it knows it's a decimal. So this one's going to be detail 2, because I don't need to plug in the iterations there, and then this one's going to be asset name. Plug you into there. Why you do this to me? String it is there. Sorry, this is now it. Okay. Let me just go into here so that that error goes away. So we now should have two. Why are you not giving me what I want? This should be giving me what I want, but it's not. I'd love to know why it's not giving me the current detail. Because that's an integer. That would help. Okay. So this is going to be version 29 piece 9 sort of thing. So now they all have unique pieces, unique names. Okay. I'm now just going to say multi-thread turn off. Actually, no, I want multi-thread turned on. I'm going to turn off the max iterations. Okay. My voice is getting sore. Okay, so now we've got two ones here with like unique names, and the other one without unique names. So now we've got this one here, which is now going to transform this. I am going to patch this out so that I don't have to waste time waiting for it. So let's just go sim. What have we got? What's in the sim? initial cache. So I'm going to say first break. I'm going to put that into a folder. First break as well. $4, sorry. I'm just going to save that to the disk. So now they've got the age and they've got the that kind of working, if that makes sense. And now the reason it's taking so long is now is because it's just trying to save the stuff. Just FX sim. Which one was it? First break. See, it's just trying to save it. So this is what we call an I/O bottleneck. Oh, input/output bottleneck. And this is an SSD I'm using. But this is going so fast that it's just taking time to cache out. While it's taking time to cache out, I need to go get a drink. I should be back. I'm just going to mute it and I'll be right back. back. Let me just write out what it was. Okay, so that's all that. So they're about the same size each because they're not really moving, and they're only saving out the age, the name, and the point attribute. So I'm just going to say load from disk. I'm going to disconnect that, so that's we're going to get this. I'm going to rename this first break big input. Did I spell input right? I did. That's brilliant. Let's color this. And now I want to unpack it. And now we're going to see we've got name and name. So I'm going to say attribute delete. Actually, no, rename. Attribute rename. I'm going to say override existing attribute. And instead of name to name 2, I'm just going to say name 2 is name. So name from name 2 to name. So now, invalid specification name 2 not found. That's a primitive attribute, right? Always muck that up, don't I? Primitive. Name 2 to name. And now, should now have name just being that massive amount of points. Okay. And now we should have an age, so I need to unpack. I need to say transfer the age. So now, if we do a color between the two, we should have like this little faded thing. And I'm not too sure if I want it to be on the let me think. So now that I've split these up, I want to simulate this again, but this time having the it breaks apart over time sort of thing. So I'm going to grab this bad boy again, cut them all out. I'm going to go to, this is my first input, this is going to be my second input again, so I'm going to use the same one. And inside here, I might even change it later. Inside here, I'm going to put down a sample. Okay, I'm going to turn off the create name. I'm going to say create pack geometry, and I now want to promote the age back up to the points. So now I've got the points and the age here. So now if I color that, it shouldn't color anything until I promote it back to here, like so. And now we can see it's working. So I want to fit range this because I now want to group it. So I'm going to say I don't know if we can group it using this. So the easiest solution for me, I'm just going to disconnect all these. Going to get rid of this one because that was the grouping thing that we had. Go all the way up to here. Up. Let it cook quickly. I'm going to plug it into there. So now we're going to get the points working the same way. I'm going to say I want to group these if it goes over a certain age. So if the f at age is greater than, let's say, so So this is going to be like do we want to do like a group, or do we want to do it more of like a, let's just do it with a group for now. If it's over the age of, let's say, 40 frames or 50 frames, okay? If it's over that age, then I want to say at group, group, let's say act is 1. So now this is going to activate, put them into a group, point group. So that's how we write out a group inside of a wrangle. We put down the name group first, we do an underscore, and then we write the name of the group we're going to say. So as you can see, I now have a point group called act with no points in it currently. So if I now do a color again, and say, hey, just go over the points that are in that. And we might promote it again. So let's just simulate a few frames. And it shouldn't do anything because it's just grouping it. Let's do attribute promote again. And we're still not getting anything inside there. Okay, so if age is over the frame of, hang on, is age not coming properly over? Let's take a look at you. Okay, if the age is over 20, let's just say its age is over 20. That was too small. Reset it. Let's go back. This is a lot faster than the RBD we did last time. I don't know why it's not getting. I would love to know why it's not actually moving. You know? Why is it not moving? So, I'm just going to copy this code. And I'm going to delete this and make a new solver. Yep, solver here. Plug you in. Turn you off. Stop. Go. You wrangle. Plug you in. And let's try that now. Hopefully this actually is starting to go. Why are you not moving? Like far out. Let's previous try fetch geometry from .network. Alright. Let's grab that like this. Okay. Now then. Okay. So, I don't think it's getting the previous frame properly. So, let's say float A is it's going to say point 1 age at the current point. If A is over 20, then put it into the group. Wow, why is that so slow? Oh, because it's doing all this unpacking and packing and stuff like that. Now that's a lot slower. Great. It might actually be working now though. So if that's good, then I need to cache this one out again. Because the packing, unpacking are quite slow comparatively. It's not bloody working. Right. Okay, time to close. Houdini. Let's restart it. Loop, loop. Recent files, dust effect 2. Wow, that's a lot of warnings. none of which we need to worry about. Let's go solver. Plug you in. Let it cook. See, it's getting the previous frame. Not even, actually, not even getting the previous frame, is it? Solver. It's getting this frame. So let's figure out why. So let's go to what? Ah, that thing. What is that? That's my, so it's like my company name, I should say, for here working here in Australia, but I don't really do that much work still yet. I only just graduated from Murdoch, as we can see. So let's not look at my GPA, shall we? So I've finally achieved my degree. I should be graduating in a month time, I think. And I'm actually going to start applying for work. Well, I am starting to apply for work in studios around Australia now. Because I've worked in small studios, but it's I want to work at the larger ones and stuff. But that name is like a registration that I had to make for be able to work properly in Australia. So you have you have like different types of businesses you can make, and different taxes apply for them. And so I made the name CG Dingo, because why not? Okay. Let's figure out why this solver isn't actually getting my inputs properly. So we may have to do a little hacky workaround. First of all, I'm going to cache this out again. I'm just going to add a number to it because I'm very lazy. Oh, this is going to take some time, isn't it? So just to showcase what I'm trying to do is I'm trying to say if once it's over a certain age, activate that group. Once you've done the group, then keep following the path, but this time break apart a little bit. And once it's breaking apart, what I want to do is I want to say, okay, now just like dissolve in a sense. So shrink away from where you're going and replace that with the particles. And then we will do an actual pop sim behind that. And after the pop sim, we will do a smoke sim. And then we would continue on with what we've got going. And we will render it, but actually, while waiting for this, let's install Redshift. Redshift. Yes, yes. Oh, it actually did something. Nope, nope, no. Good. Yes, 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 yes. And yep. Next. Yes. Oh, hang on. No, yeah, that's correct. Yep. Uninstall. It's not going to mess with Houdini because I've got in where is it? Packages. I've actually got like a proper setup for it already. So I don't need to mess with like the versions or anything like that. If you're wondering about this is a tutorial that's still in the making. because I have been rather lazy in the sense of just because I had to reset my computer and I kind of just forgot to edit the file still. Speaking of the licensing, I need to update the licensing of that soon. I think it's about to expire. I think this is about to expire. Let's take a look. Proof services. Manage your licenses. And... Oh no, next year. Okay. At least I was smart on that front. Yeah, this one's taking a bit longer, but it will be a bit quicker on the actual IO part. Where is it? So let's see, 139. So it's kind of staying up with it now. Beauty of simulation. I remember I was doing one of my first jobs was making like a helicopter crash, unpaid. But I ended up spending a majority of my time sitting there playing on my phone, waiting for it to actually simulate like this. That's done. Let's try and make this stupid solver work now. Far out. This is just killing me. Why is a solver not working? You know? Um hit stop. It is going a bit slow now. Still not getting a load from disk. It's a wee bit faster. Being roasted on my friends group chat. Brilliant. Okay. That was only the first input one. Far out. I want the previous frame. Show me that you are working. This piece should start moving soon. Nope. Okay. Cool. Okay. I can take it. Don't worry. That's fine. That's fine. I'm going to copy this stupid wrangle. And yep. And yep. And yep. It is taking a little time. So let's try and do it without the wrangle. Let's try and do it without the solver now, actually. So I'm going to turn it off. And what I'm going to do is I'm going to copy this because I want to change it. And this time I'm going to do the for number thing. I'm going to plug this in here. Plug this one into a VDB. Yeah, it's a 32 system, 32 one. Add vect points. So this one plugs in here, this one plugs in here, this one plugs in here. Come on. Add vect. Okay. Cool. Now it's advecting that. It's not what we want. We want it to advect the points only if they've been moved a little bit. So what I want to try and do. So let's. So honestly, this is still taking its time because we're now moving like we've now got like 55,000 different points. So what I'm going to do is I'm going to do an attribute wrangle here, and I'm going to group it like I did last time. So I'm going to say if at age is greater than let's say 15, then group at is 1. If it's not, then so it's always if it's over the age of 1, then you're always going to be active. Okay. So then, don't think this is going to work, honestly. Let's just go 1. Let's just say it's just going to do 1 frame, sort of thing. At the points, it's going to run over the ACT. So now, yep, okay, over the points act, like so. Okay. So now we're going to see some small sort of breakups happening here. But it's not really what we want. We want to have them like go over time, which is really annoying. Why the solver isn't working? Because the solver would fix this. So let's put down a pop solver instead. Let's try to do it that way. I'm going to copy that, plug these two into here, and let's just try and do it in the pop solver. Turn you off. Thank you. You are going to be all points. So let's scatter. And we can see we've got quite a lot of points. Let's turn off the guide. There we go. Go here. What should happen is these should not move. Forgot about that. So I don't want them to birth, sort of thing. I want them to just kind of activate, if that makes sense. So let's try and do a rigid body solver, and it's going to be slow as hell. Object, first input, back it up. Okay, there we go. Let's just see how slow this is going to be. Wow. Yeah. That's very slow. So I think I cracked it too much, possibly. Yeah, it's trying to solve itself. So I wonder if I can make it not solve itself. So I say don't solve for self-intersecting once, because this would technically be self-intersecting in its own right. Come on, hit escape. So it's using my CPU quite a bit. My GPU, my memory's fine. Stop. Oh, it is cancelling. Maybe it's not cancelling. I don't know. Okay. Can I say don't? Should be performing. Okay, so that's probably not going to work. So the solver really is my only other option we can use. So solver. I just got to think about how we can actually do that. Alright, so the solver's not actually going to do anything unless I'm outside of here. So I'm going to pin this, and then I'm going to dive inside here, and actually going to go. So yep, cool. So I'm going to have to deal with this one here, and then add to the previous frame. So we're going to grab the first input. And again, so I'm only doing this because I want to make it a bit high res, but honestly, this might just be a bit too much. So I'm going to go down back to here where we had the initial, the whole thing actually start. And I'm going to adjust the amount of fractures we're going to get. And afterwards, I would make it more of like a high quality. And I need to make sure that it's, so this is the old fracture, so this is the initial fracture that's going on now, and now it's doing this fracture here. So what I want to do is I'm going to go to here. I'm going to say just do a few of them. This one's giving me 360 from 50. Let's change that. So I'm going to switch it. So I'm going to make a switch. Plug that into here, and plug this one into here. And so I'm just going to say low. I'm just going to shift R. That's just going to switch it. And I'm going to change this from 1 to 2 to about 3. So that way it's not going to have that many points. So come on. Come on. Come on. How many? 128. So that's kind of halved it a bit. So let's just turn you off. How many do we have? Oh, come on. So now I'm going to just recrash this out. So this one's going to be, this one's going to be low. The low res. And this one's going to have that same issue with the I/O, where we're only up to like frame 10. And this is already finished up to like 240. I am trying to make sure that we're not going to be sitting around just watching these frames work. Computing does definitely matter, so the computing power definitely does, but it's something I've had to struggle with myself. Honestly, this is probably one of the most tedious parts, just sitting here waiting. Okay. So now we're unpacking, running the attribute back up, we're assembling. Cool. There we go. And I'm just going to calculate this back too. So let's hit low. This one's called low. And save you. Annoyingly, I would love to have it so that the unpack I could just change the amount of pack pieces, but I can't dynamically. So this is the best option. We just unpack, transfer the attribute, and then we repack it. More Hong Kong riots. How wonderful. Okay. Let's see if this solver runs faster now. Why did it just back go? Stop. Why is it not liking stuff? You off. You reset. Back. Go to here. Let's go frame 24. It's nice and fast now. Well, faster. Try looking at the previous frame. Still nothing. Okay, so let's grab the first input. What we're going to do is we're going to say, hey, if in group act, so I'm going to say attribute wrangle. Actually, I say VDB add back points. Say, hey, if let's try it with the previous frame. Let's try actually plugging it in the volume. Just go on the act. Here. Go. So I don't think it's going to bring in the transforms, but it should at least start to work on the grouped points. Doesn't seem to though. Very unusual. The previous frame should be grabbing in the right ones. It's not. Because it was doing... I guess it wouldn't be. Okay. So, let's grab you. So it's going to reset it every frame though, that's the problem. So I need to make sure that it adjusts after the frame. So it adds the difference. If that makes sense. So we should see like some splitting happening. So we're seeing some splitting happening like right here, but it's not, it's happening like every frame. So what I want to do is I think I'm going to say, hey, attribute wrangle, if the if it's in the group, so if at group act equals 1, then get the current position from the previous position. So pos equals 0.1 p. But let's try and do it with the names. So let's go. Int point is find attribute val 1 is a point group name my name. We want to use the point here. So at p equals at. Okay, let's go. I think that's working. Kind of is. So now what we will do is we will take this volume up. Let me go here. Let's do a volume trail. Hopefully it will work. I'm just going to disconnect a few things. So just cleaning it up. Volume trail. Let's take a look. Make sure you are actually working. Yep. I want to just add a bit more detail to that. So how I can do that is I can grab this. That's going to add a little bit more detail, I hope. to make that sparse convolution. I'm then going to increase this to maybe 15 instead of like 5. I'm also going to decrease this down to about 0.5. Oh, let's make 0.7. Okay. And let's try that out. I think I'm getting a headache, so I'll be right back with some Panadol. Okay. Are you still there? Okay, cool. So now we're getting the secondary fracturing, which is what I wanted. Um, hmm. Let's add some more noise to that. Let's add U, which is, let's add sparse. Make it 3D. Check to make sure what we're doing is correct. Make it 0 for now, see if it changes anything. 1. Let's say 5, let's say 3. Yeah, okay, whatever. And let's say just increase the speed just a little bit, so it goes a little bit faster, maybe. And so what we're doing is we're saying once it gets to a certain limit, just disconnect from the initial animation and keep going with the advection that we're giving it. Okay. Is there anything you're unclear on? Is this simple enough? Because I really hope it's simple enough. Right, and now, so now what I would do here is I would do the very high res simulation. But for sake of simplicity, what we will do is we'll now add some particles. And how are we going to add particles? So the way we do that is we're going to do the same thing here, except we're going to be scattering particles over it. So I'm going to say for each name primitive. So go here, go to here. I need to unpack these too. So let's say unpack. Plug this in here. Warning, no attribute name. So yep, name's there. Don't know why it's not saying the name is right. So it's going to say for each named attribute, plug you in. Okay, there we go. And then what I would do is I would now scatter some points. I'm going to turn the relax iterations off. And it's going to scatter like 1,000 points on each one. And that's not really what I want. I'm going to scatter about 100. Yeah, about 100 on each. So 100. I'm also going to do a time shift because I don't want these to move. Turn off. Delete. And you're just going to be frame 1. So I don't want this to move because otherwise it's just going to scatter every time. And I don't really care about that. Okay, so now I need to transform these points across. But these don't have a name attribute, so let's give it the name. So it's already getting that. So what I'm going to do is I'm going to promote. So I'm just going to say attribute wrangle here. I'm going to make a name. Stop it. Come on. Let's just do 50. Thank you. Okay. So I'm just going to say s at name equals primitive 1 name 0, because it's just going to be because we're going over each name anyway. I can just get the very first one here. So now we're going to have a name attribute. Turn off that max iterations. Now with this set transforms, it's now going to transform this. Honestly, I could use the transform pieces, I think, and it should still work for the points. Yeah, it still does. Yeah, cool. And now what I want to do is I want to set the correct an emission field sort of thing. So I'm going to give it that. Can we use debris source? Yes, you could. But I think the debris kind of takes into account something. So let's just try that. Let's try debris. Go in. Let it calculate. So yeah, it's got some stuff going on here. It's not really what I wanted though. So what I'm doing is I'm making all these points, and then I'm going to delete based on their new age here. So what I want to do is, so I've got initial age and we've got secondary age. So I'm going to make a new age here. So I'm going to say attribute delete. I'm going to get rid of the age because I now want to make my own age here. And I also want to copy over the age. So I'm just going to say age. There's not any age here for now. I want to also delete the age from here because I want to get a different type of age. And now, what I want to do is I want to say basically if in group. So it's basically going to be the same thing here that we've got. So time solver here, chuck you in, throw you in here, and once it's in the this act group here, then it's just going to add to the frames sort of thing. Okay, so now I'm just going to go over like this way so that make sure we're getting the age. So the debris source, it takes into account a few things. It'll take into account like impact data and so on, and because we're using a SOP solver instead of like an RBD one, it's not going to have a lot of the data that it uses. So it's just going to try and guess based on certain velocities. What I'm going to do here is I'm going to use the age and I'm going to gradient it off so that it basically only a certain part of it is going to be moving. So what I'm going to do here is I want to calculate the velocity. So I'm going to put down a trail node. I'm going to say compute velocity. Now we're going to have like a small velocity field sort of thing. And I'll show why that is in a second. Actually, no. Okay, so I got that one. I also want to get the normals. So let's take a look at the normals. Whoa. That's massive. Why are the normals so big? So, take a look at why the normals are so big. Massive. Okay, but we've got normals and we've got that. So, I'm going to do like a little trick to make it so that only one part of it is going to be creating particles. But for now, I want to, so we've got the age. I want to make a Ashford wrangle. Let's make a point bar. Ugh. Hate it when this does. It happens. The tab kind of menu kind of just ruins itself. So let's plug it into the color. The H. So bind age. Age is going to be, I think it's going to be an integer. Start is, I'm going to say integer. I'm going to say float. Int to float, because I just want to mess with like an actual float value. And then I'm going to say fit range. So I'm going to say fit range between 0 and let's say 50. Let's figure this out. So between well, start back in here, and let's say between u and let's say 40, and u and 40 as well. Okay. Between 0 and like that. So let's take a look at the age. Age is just 1. Why is age just 1? What group are you in? You're in the activated group. Oh, right. So I need to get the age from there. Right, okay. So I'm going to say if it's an age, then I'm also going to get the age. So I'm going to say f at age plus equals is equal to 0.1 age point plus 1.0. So now I'm going to get an actual age coming across, I hope. So let's just quickly reset and check. Alright, so I need to actually do a few frames before it can actually start. Puzzle pieces, this thing. Okay, there we go. Now we've got like an age thing kind of working. So I'm going to say age is going to be like, let's say about 4 between that. And even then, we could have it so that it kind of disappears over time. So inside here, we could say channel ramp, that sort of thing. And inside here, we would say spline ramp. And I would put that in the middle and then split down like that, so that if it's over a certain amount of time, then it will start to die, sort of thing. But for now, I don't want to do that, so I'm just going to go like this and keep it linear. How long have I been streaming for? You can't hear me. Can you hear me? Can you still hear me? Okay, cool. So now we've got that. I'm just going to blast them. So I'm going to say attribute angle. Oh, you can just use a blast really, so that will make it a bit simple for you. So at CD dot x is less than 0.1 sort of thing. Then we set it to points, and you'd probably make it like point, yeah, that sort of thing. And then I would just delete the color because I don't like seeing the color. Point color, like so. Now I wanted to show you that little trick with this trail. And the trick here is I want to have it only being put out tangential to the velocity. So the way we do that is we grab a point bop, yeah, dive inside, and we do something called a dot product. So dot product, and I want to do a dot product between the velocity and the normal. And I'm going to normalize these two because if it's not normalized, then it kind of mucks it up. So now you can see that if the velocity is following a certain way, I'm hoping, yeah, if the velocity is pointing one way, the points are going to be white. If it's pointing another way, it's going to be black. This goes from -1 to 1, so I'm going to refute it. My voice. And then I can do a channel ramp again. And again, I can do like a blast. And so this one, I want to get rid of the ones that are facing forward, I believe. No, other way around. I want to get rid of them like that. And then I'm just going to, oops, do another attribute delete. Okay. And that's just something that a little extra that you can do with that. So now, what I'm going to do is I'm going to make a pop. Back again. This one's the second input. This is my volume. That thing again. Plug this one in here. Jump back up. Say all points. Let's see it going. And it's bringing in the velocity. So we want to kind of like tone that velocity kind of down. So inside here, let's say inherit velocity by 0.05. So like a minor amount of the velocity. Okay, so honestly, I probably don't even want the velocity that much, so I'm going to set it right down. I'm going to put my simulation cache up a lot higher. And I'm going to start by bringing in the pop add back volumes. And I want it to be, actually no, I'm just going to say pop force. I'm going to say 1, say base it on age, amplitude by age. Swirl size, let's make it, the swirl size quite big. Let's put the amplitude down actually a little bit. And let's just see what that looks like. So we're getting something like that, which isn't quite what we want really. So let's, for starters, change our view from points to pixels. So we can see what we're dealing with here. Let's turn that inheritation back up to 0.2, maybe, sort of thing. Let's add to it, like a small amount. And let's do a backwards jitter, so that it doesn't have like such a harsh feel. And let's just turn down this just for now. Let's say like 25. Let's say 30. Okay. Hit back. Turn this thing off because that's actually slowing it down a little bit. And now it's having to recalculate the SOP solver, unfortunately. To view this a little bit better, I'm just going to change my background from grey to dark and hit go again. And I think the variance is a bit too much, honestly. So let's turn that variance back off. Let's go use inherited velocity. Let's just set back to 1. And ideally, actually, instead of this trail, I'm going to set the velocity myself. So there's currently no velocity. I know the velocity is coming in from here, in a way. So I'm going to say aspect angle. It's all right. I've stayed up later before, so I'm going to say let's use a point block so that you're not lost. Okay. Now I want to add to the velocity, so the velocity is going to be going the wrong way, by the way. So I'm going to say volume sample vector, because this is a vector field. Current position is this current position. Primitive name is velocity, and our file is the second input. And I've got my caps on. And I'm just going to plug that in. And now we can see we're actually getting the velocity. So we don't have to sit back and wait for it to calculate. Besides, you know, it's late, but I've got chocolate here, so. Okay. So I'm going to turn the swirl scale up. So I'm actually going to turn this off. And I'm going to do the pop-out effect again. Second input. Set it to about 0.3. And hit go again. Like, honestly, I would use this sort of stuff as my reel. Just all this teaching that I do and all these live streams. But sometimes I can't for like legal reasons. And every time I tell people that, or I tell potential hiring people that, they say that I'm saying that I'm lying. It's quite annoying when they do that. Okay. We will probably have like an age over here. So let's say the age is like 1.5 with a life variance of 0.2. Hit go. This is the good part about having a lot of RAM, though. I can just set the cache size higher and wait for it to simmer, then I can watch it play back in real time. Well, relative real time. So I'm not too sure if it's behaving the way I want it to. I think it's moving too much with it. So I am going to go to here. Okay, so velocity is the velocity here. And I'm going into the velocity. And I'm going to negate it. So it's going the other way. Let's just dive inside here. Turn off this advection. And let's turn this back up to 1. So I want to see which way it's going. Yep, that's the way I want it to go. Honestly. It's going a bit too fast, obviously, but it's going the right way. Put down the pop drag. Set it to 0.05 because pop drag is quite aggressive. I might have to push it up a bit higher though, honestly. And I do want to have some form of clumping, honestly, but we can set that later. So I'm going to set to 1.5. I'm going to set this to here. I'm going to say velocity scale is -1. So that's going the other way. Then I'm going to turn this on. I'll put it to 2. Set this to 1. So it's going by age. And let's just hit play. So I know you don't want it to get too complex, but honestly, if you don't get too complex, like, well, this isn't really complex, but if you don't, okay, so this pop drag thing here is going a bit too aggressive. This pop force, I mean, is a bit too much. So let's put it back to 0.7. But the point of creating good effects is the layers. So we're just layering on different things. So I did the first initial breaking where the instead of going into like a rigid body solver or a pop solver, I just did it to the sub solver. Honestly, I actually might turn down the incoming velocity too. So I did the initial breaking with like larger chunks, and then I did the secondary fracture where and I kept the same transforms, but then I added to that afterwards. That one's just going. I think the age is not going good enough. So let's turn the age to like 0.5 and the variance to 0.1. And we look like we're getting a bit of such substepping here and there. Actually, this isn't that nice. I'd like a bit more variance, so 0.35. So it's going to be quite a lot bigger, if that makes sense. Let's go negative jitter. The difference being is that it'll take the velocity, and when it's born, if the velocity is a certain point, it's either going to push it back or it's going to push it forward. And it tends to be good advice to push it back. Okay, so that looks like quite a lovely mess. We should try and get a bit more clumping in there though. I'd like to have a bit more clumping between the pieces, honestly. Because right now that looks quite unorganized. So let's see what we can do about that. So there's a technique that Saber taught in the Intro to Effects course. For all those who are listening who are not from Railway, hello. Object here. Choose particles. Yep. I don't think it's going to work so well here though. So, but each one has like a unique name. So that'd be nice. Let's color it by the unique names and see what we get. This is color random from attribute by the name. That's kind of unusual, honestly. So let's see if we can clump it together. So we've got a particle pop. There's a few things we've got. We've got like a pop proximity, I believe, which it tells what to do itself. Wrong thing. You've got flock. Flock is kind of like voids, so that's not what we want. Let's take a look. There's a pop look at, and then there's like a pop. There's another one that I want. Might be grains, honestly. So it's not the right one. Let's take a look. Let's just quickly Google it. It could just be the third. Grains. So this looks like it's a solver, honestly. That's not really what we want. Apparently there's a pop interact. Yep. Okay. Let's try that then. So pop interact, position force, velocity force. So it should, ideally, attract to one another. So let's take a look at the documentation. You've also got like a pop fluid, which kind of helps, I guess. Let's try that one instead. Let's try the pop fluid. Turn you off. Particle separation, that's fine. Neighborhood size, yep. Okay, let's just go a few frames and let's see what happens, because this is just, we've moved from my brain dying to kind of working, I suppose. Brilliant. So let's try this one. Interact. So this is like how strong they force each other apart. Let's skip that one. It's not quite really doing it. So let's instead. So each one will have so that's how many unique names we've got here. 700 unique names, and it should be the name should be carried over, honestly. So let's take a look. Thank you for telling me what it was. So we should have. How does it give me unique names? Just take a look at the names here. How many did these have? 1173 and 173. So instead of grabbing those, well, there's no real way we could do it, is there? So what I would do is instead of having like that, I would. So I would keep the name instead of like deleting it here. I would keep the name. So what I'd do is I'd say name is name 3, name old, and then 2 to name. So now if I grab that, we should now have name old about 7,000, which is what we had before, and name new is like 1,000. I'm just going to quickly cache this one out because then I can. Too late, it's fine. I don't mind. Being late is fine for me. I don't. My sleeping schedule's already messed up. Besides, I'm just probably going to hop on a video game after this to you know, de-stress a little bit. You're not troubling me, don't worry. Yeah, I could probably go for 1 more hour more, but after that, then I'll probably have to go to bed. We had a cyclone go through the just underneath. Where was it? Let's see. So let's go to the maps. above. Okay, so where's the map? Here we go. So the cyclone went basically down this way, like that. It hit some places like Kalgoorlie, which is bang in the middle, right around here somewhere. So it went down that way. And it's kind of destroyed quite a lot of houses and stuff. So that was fun. We just had a lot of heavy rain and winds. We didn't actually get like the proper cyclone, so it missed us. But that's what the news has been about in my country for the past day or so. All right, so we've got the solver here. We've got this. So we've got name old, name old. I want to make sure these still have the name olds though. So s at name old is primitive 1 old 0. Just let it calculate quickly. Yep, name old. Now transform these pieces. Cool. There's the attribute delete. Cool. Let's just reset you to the first frame. And let's. Why have I got that? Let's go hide after objects. There we go. I'm gonna hit go and sit back and wait for a little bit. And the reason I brought the old name back is because I don't like this. I want to use this one. So we're going to have a little bit more, less variance of what we get, and we can color it between. So we can say ramp between from attribute, name old sort of thing. And what we would do here is I'd say attribute wrangle. So we've got two methods that we can use to color it. We've got the at CD equals, actually let's say f at speed equals the length of a velocity. And let's take a look at what that is. So the speed is pretty small actually. So the reason I did that is I'm just going to turn this off so that it's just a float. I'm going to say at CD equals channel ramp 1. Say speed, so bit range, speed from 0 in to 0, 1. I'm also going to tell it this is a vector. So that way it will automatically go here. Then what I'm going to do is I'm going to check quickly. So flip object, guides, particles, color ramp, copy. I'm just going to paste it in there. I am lazy. And now we've got like a like this ramping attribute here that we can adjust. We've also got speed. We've also got another way we can do it. We can say this. I'm going to say random between. Well, how do I do this? So this is a name, right? So this name is name old. So got a name old, got a name. So I think we need to do like a I don't know if it'll work. So it's at cd equals random s. Yeah, it doesn't like a string. So type in Houdini randvex inside to Google. We've got a few randoms. We've got something called random s hash, I believe it is what I want. So this is going to give us like so if you don't know what a hash is, it's something that we use in cryptography. Cryptography being like encryption, password protection, junk like that. A hash is like a secure thing, so that nothing should technically be the same. Unfortunately, with Houdini, the names could, two different names could give you the same hashes. It's just how random kind of works. So we say s random s hash, I think it is. That's now going to give us like this random thing here based on the name, which is what the randomizer was doing anyway. But I want to say vector and ramp 2. Fit this one. Let's just say 0 and 1 for now, because it's just going to be 0 and 1 anyway. So this isn't really changing anything. So what we got wrong here? Okay, that needs to be there. And I have gotten too less. There we go. Now we can like randomly affect this. So I can now say times equals this. So randomly I'm now selecting these random parts. So I can say constant sort of thing. Let's change this to like a red. Let's change this to a full and white sort of thing here. Some of these kind of work, some of these don't. It's kind of weird, kind of arbitrary how they would work. So let's just make this, let's just go with grayscale sort of things. So one, that, so we get like a grayscale here. I can create a few of those. This one wants to be constant as well, so constant. I can create another one here, create another one over here, and so on, like that. And now I can basically change this based on the ID of the particles that we're emitting from. So I've got that, which I kind of like. I'm going to change this to a more of a browner color, so more like a, let's go brown. Colors are not my forte, if you didn't know. Let's try like a dirt brown like that. Get rid of you. Put you. Let's make you a bit lighter. And you'd basically have like several different ones. So you'd make this one like very dark here, and you wouldn't have like a full white either. You'd have it more. You'd have it tinted a little bit. So I'm going to tint it a little bit yellow. And honestly, that's not really coming through, is it? So if we turn the min back down a little bit, now we're actually going to get that. So I'm going to bring this back to a bit more of a reddish, an orange hue, like that. And then what we could do is you could do something like a technique that I remember seeing Saber show me, is we can do 2 of them here, and we have this one here, and we just change this very drastically. So this works great when you're dealing with like when you're trying to make rocks and stuff. So we've got that one. So that's kind of alright, I suppose. What you do here then is you would increase the amount of particles here, so that you'd have a lot more to work with. So let's just increase it to about 200 for now, just very quickly. I'm not going to do that many frames with this one, but we're going to do it to about 65 frames again, and we're going to see how that changes it. Let's go 70 frames. You keep typing and then you keep stopping, so you can finish what you're typing. You know. If you've got a question, just ask. So it may not be available tomorrow. There we go. Some of these are a bit too black, so I bring these up. And then I bring this one up a little bit as well. And just be a bit careful with that sort of thing. With this method here. Make it lighter. Also, we're getting some things here. Just be careful of those. Ways to get around that is just increase the substeps. Can I get this video here for you can get the hip file, mate, if you want. But if you want this live stream video, I can download it for you and you can send it to you. So let's try and get a bit of clumping going on as well. So I don't know how well this is going to work actually. So one of the things that Saber showed us was how to get remove points that are just flying out. The way we do that is we go point bop. I'm just going to go to here so that we're getting this thing. No hip, not hip. So you can. Do you want the live stream video then, or a flip book? So so I might have to do this in backs. So I'm going to say right. Yeah, you can. Yeah, you can. I'm pretty sure you can rewatch it after as well. I'm not going to take I don't take my videos down. Let me see. So I'm going to say for each name primitive, I'm going to say it's a point, name bold, 390. Yep, there we go. This is just a easy way of instead of having to write everything out in vex. So I'm just going to say let's just do these ones here for now. I'm going to do point bop, and you've got two options you can do. You've got the point. So we're going to do another point cloud open. First input into the first input, position into position, and we're just going to promote these up. And then we can say num point number found sort of thing. And what you would do is we would then plug that into the CD. And we do a fit range. So we fit range this between the max number of points and the minimum number of points. So then we would say, okay, let's say 800. That's too many. Let's say 40, and then we'd say so PC number found. It might not be PC open that we want, honestly. We might want something else. So find PC find, and this is going to give us the amount of this is going to give us an array of points, similar to what the PC num thing is going to do. So plug this to here, plug this into here. I'm going to say integer to float, so that I get the right one. Let's say radius, max points, and then the radius I'm just going to push up. Then I'm going to put down a ramp. Let's see how many we're getting. So it's just is getting everything annoyingly. So let's pull this right down. And instead of plugging this into that, I'm just going to delete that. I'm going to say max amount of points, and I'm going to increase this sort of thing. And so now this is, you can see how it's calculating how many points are closer to each other, basically. This kind of counts if, so I'm going to say 10, 20. What I could do then is I could just say, oh, if it's close, then just pull it together. Or I could say if it's not close enough, sort of thing. So let's set this to about 0.5, then remove. So I'm just going to turn off this max iterations. And what I could do then is I could say blast. And I need to make sure that these are integer floats, float integer floats. Yes. Current position is here, of course. So then it will actually get over it properly. And I can say at CD, that's at CD, x is less than C02. It's a point thing. Let's turn it off. So you actually see it. Let's set this to 10 again, and let's see what's happening. Looks like it's finding all the points that it needs. Let's turn it right down. So now we're only going to get like the streams that have a set amount on them. Blast. Yep. Yep. Okay, and then attribute delete that color. And this gives us a bit more of like a wavy thing. Still don't like this. That's a bit annoying. Don't know what that's coming from, so you would have to look into that and investigate that yourself. But just keep in mind that this thing can take quite a while. Another thing you could do is instead of doing it like this, so I'm just going to go back. There we go. We could clump them together. So what we would do is we'd say, hey, if all those points that you found, so I'm going to say for all these points, disconnect that so it doesn't error out. For all these points that you found that are out of the range, actually, how would you do that? I don't know how you would clump it together, honestly, because you need the inverse of what it's not what they're not what the point cloud is not finding. But what we could do is we would say, so it's the first input, point group, whatever, and we would increase this to be about 0.2, I'd say, or less, and then we'd say do it for each loop. Get that, and it should be giving us the point number. So we're going to say import point attribute, which is going to be the P. So I want to get the position. I want to say if, so I'm going to do a condition. I'm going to get the distance between this position and my current position. And then I'm going to do a condition. Compare, sorry. I want to say if the distance is greater than, let's say, so this one's point, this is search radius. Let's make a new attribute here. I'm going to say search fall off. If it's greater than that, then I want you to then, and I'm going to get that position again. I want you to say mix this and the second, the current input. I want to mix these two together to 0.5. And then I'm going to say next out and plug that into the position. So I now need to increase this. Come on. We should see some movement. Well, that's not nice. Why is it not working? Let's do it with a wrangle. I think we're steering into the wrong area that we don't want it to be. I'm just going to use this one. So do the same thing. I'm going to say int points is PC find. So I'm going to say 0 p at p channel float radius, then channel intimate max points. So then I'm going to say for each point, for each int point in points. So I'm just going to make the radius be about 0.4, max points about 20 for each of them. Now I'm going to say get the distance. So I'm going to say vector pos, float dist is going to be the distance between the current position and the point position. So I'm going to say vector pos is going to be 0.0 p point. Is that what I did wrong over here? Am I getting the wrong? No, I'm getting the right one. Okay. I want to get the distance between these two. And I'm going to say if the distance is greater than secondary radius, then I want to set the position. Oh, I need to set the position of that one. Right. I want to say vector new pos is going to be the linear interpolation between this position, this current position, by 0.5. And then I'm going to say set point attribute. I'm going to say this is like a setting of a point attribute if we're not on the current attribute, the current point I mean. So I'm going to say 0 p for the position. We're going to say we're going to set up the point. We're going to set the attribute as new pos. I'm going to say set. And you can see that's moved some of these points around. Then what we could probably do is we could do like another for loop for like the amount of iterations. So let's see it. So we say secondary radius. You can see it's kind of clumping it all together. We would probably make this quite big, quite a lot bigger, sort of thing. So we'd say about 400. But then we're going to get something streaky like this, which isn't really what we want. Even then, we would have like this sort of thing going on here. Alright, if it's less than a certain amount of points, so you don't want it to be doing too much, obviously. So we get that. It's just going to clump it a little bit together, which may or may be not what you want to clump. It's going to call it clumping. And then I'm going to turn the max iterations, and we're going to see how long it actually takes to cook that. Quite a while, it seems. But the beauty of doing all that in a vop/vex function is that I can compile this. Multi-thread. I'm going to move you out so you're not even going to be part of it at all. Plug you in, turn you off. Now we can see the difference that kind of makes. But do be aware that it could kind of ruin your simulation quite a lot. So it's not quite recommended all the time. Add smoke for disappearing. I am going to be doing that. So, but that's this working now. Still getting some really unusual velocities. Let's make sure that it's not coming in from, say, here. No, it doesn't look like it would be. But just in case, let's scale down this. So let's go normalize. We can even normalize it. Nope. Let's try not. Let's not normalize it, maybe. But let's. No, the scaling down is already happening here, isn't it? This is already scaling it down. So I would love to know why it's sometimes just shooting out like that. Let's go positive instead. Let's go use point velocity, which I don't normally like to do. So 0.3. No, don't move overlapping, I don't care. And inside of the simulation, I'm going to do 2 subsets. Normally, you could also, whoops, go back up. You could also put the number of subsets here, so let's say 3. Instead of that, I'm going to say back to 1. I'm going to set this to 2. This is going to slow it down, but you might. But the idea is that the more iterations, oh gosh, the more iterations you do, the higher the quality of the final sim will be, because it's been able to do it many times. But from here on now, you would it is coming to my bedtime. Here on now, you would yeah, that looks a bit nicer, honestly. We're still getting some weird things here going on here, so maybe increasing the subsets even more would help. So let's do a wide substeps. I forgot what I was going to say. So I might be honest. To be honest, I might end up taking this a bit further later on and actually trying to add it as a part of my reel. But for now, this is how I would do something like this. After this, what I'd do is I'd add smoke. I think. And you'd also do like that make transform that I showed you before, with the scaling down of the pieces. If you wanted to do that, you'd also have a lot more than what I have. Okay, we're still getting that weird jittering. Um, I have a feeling it is because of the fact that I said use the velocity instead of match topology. Let's try forward instead. Remember, I came across an error with pop solver a few times. It's always quite annoying because sometimes the you'll take some time. Cool. Yeah, take it. Don't try and rush this. Like I've done this over 4 something hours. How long have we been doing this? About 4 hours. Um, don't try and rush it like I've been doing. Where's the particles? Stop that for a second. They're only just starting. Um, so I don't think these substeps are doing much, to be honest. So we want to increase the substeps inside the actual subsolver itself. So, because of Vex. Yes, Vex, isn't it wonderful? It shows you everything you need to do. I'm just going to quickly push this right up. Because I really am hating how it's doing some nasty things there. Yes, Rance still got to teach me a lot of explosion work and how to play music, but that's beside the point. I've heard tales that he's not a very good teacher with music. Isn't that right, Francis? I don't think he's on. Hmm. So something that might be happening here is a timing thing. So what we tend to do is we put down a time blend, I think it is. Is that right? No. So if we put down a collision source, just so that we can see what it is, we've got this thing called interpolation, where we blend between frames, and it's just this time blend thing that we have here, which helps us interpolate between the proper one that we want. Is that the right one? Read time blend. So we've got time blend. Now if we dive inside here, we should, let's push the L. Didn't do anything, did it? So the time shifts, and you got like we should be seeing a time blend. No, they're the same thing. Okay. So, but we hold this here, and we don't interpolate anything like that. So we're not gonna. We can use that. So I'm just going to set it to by the default sort of thing. Shift range, nope, 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 fit range, nope, nope, by frame. What should happen is this should retime our simulation so that there's no like stuttering. So I'm going to go back. I'm going to go to my pop network. I'm just going to put this back to 2. And I can't remember what the difference is between some things here. So you got the CFL condition, which is like if it goes over a threshold, then it will switch to like the higher substeps. But I can't remember if you lower it or you raise it to get a better to make it go to 1 point. Come on, reset. It'd be nice to be good at something without having imposter syndrome. Okay, come on, show me some magic. You brat. Why do you do this to me? Uh, uh, uh. Back. 0. Is that what it's doing? You back. Or is it actually going outside the frame? Might be going outside the frame. I can make that bigger because it's just going to remain the same because I've got the scales all working properly. I'm just going to get rid of this retime though because it's not strictly needed. Ugh, why does it always do that? Always just does that for some reason. Last one. Last one. Yeah, well, maybe tomorrow we can continue where we left, where we're leaving off here. Um, yeah. Why does it always zoom right out? Okay, so I'm not too sure why that pushes out there quite so drastically. It is quite weird. But set it back. Set it back to what it was. And I'm going to leave it at that. The video will stay up, as I said. Once this is all over, I'll probably release this a bit more publicly. Maybe, I don't know. Probably not. Because I might, yeah. Because I'm lazy. Yeah, okay, so the velocity, like, oh, we're going to use the velocity. It's giving us this stuttering effect, which is really nasty, but we can isolate it with the correct ID. Because color, random attributes, name old. We can see that these are clearly two pieces that are there. We are still getting that quite juttering effect, which is where we would use the match topology, which is why I prefer to use the match topology. But as you can see, it's some of them sometimes it gives weird results. So we'll have to look into that tomorrow to figure that out. But okay, it is now time for me to sleep. Let me know how you go.